Hello, in this video I will show you step-by-step example for Dijkstra algorithm and topological sort. We will start with this example. I will show you step by step here. Alright. So we will start with A, and we need to list down all nodes connected to A. We have B and we have D. So A, we have B through A by 3, and we have D through A by 7. Which one is the shortest? The shortest is B. So we choose B here, A and B. And then we need to find out which one is connected to A or B. So we have C. C is connected to B, and also we have D. D is connected to B and A. Which one is the shortest? The shortest is through B. Right. So we take it here. We have D through B by 2, but we need to plus with 3. So we will get here D B 5. And then we have C is connected to B by 4. We need to plus with 3. We need to go to A. So this is path from A lah. So we will get C B 7. Alright. So which one is the shortest? The shortest is through, we get D here. Okay, we get D here. So we have D B 5. So we have A, we have B, and we have D. And also we have C, our previous C. So we just copy this C B 7. And then what else is connected? We have E. E is connected to D. So E is connected to D. So we have 4. We need to plus with B, D. So we plus with 5. We will get E D 9. Which one is the shortest? The shortest is C. So we have C. We have A, we have B, we have C, and also we have D. And also we have our previous one, E D 9. So this is C B 7. Right. So E is connected to D and C. What? D to D, E to D is the shortest. So we have this 9, the only one. So this is the final. Alright, so the 3 will be A connected to B, connected to C, and D is connected to B and to E. So this is our final 3. So the shortest path, we can conclude that the shortest path to A is 0. A to B, okay, I will just write it like this lah. A to A is 0. A to B, okay, A to B we can take it here 3. A to B, okay, then we can connect to C. A to B and to C. C is 7. And then we can take it A to B to D. To D we have 5. We take it here 5. And also we have E. A to B to D to E will be 9. So this is shortest path. Okay, you can take it here, the explanation. Alright, this is for Dijkstra example 1. So we move on to the next example. Here, Dijkstra example, we use table to solve it. To solve it using table, we need to find out. We start with A. Okay, we will start with A. What A is connected to? So A is connected to B and also connected to C. So we have A connected to B and also connected to C. So we write it in the table. We have A to B is 10 and A to C is 3. Alright. Then we choose the shortest one. So the shortest one is A to C. Alright. So next we need to find out how it's connected. So B is connected to A and C. Which one is the shortest? Shortest is through C, so we get it here. And also we have D is connected to C, and also we have E is connected to C. Then we need to calculate it here. A to C to B is 3 plus 4 equal to 7. Right. So A to B through C is 7. We write it here, 3. Right. So next, A, C, and D. A to C to D is 3 plus 8 equal to 11. So this is 11. And then we have A to C to E. A to C to E. It is 3 plus 2 equal to 5. So the shortest is 5. Alright, so I will just rewrite it here. So shortest is 5. So we take A, we take C, and we take E. And then we have B and D. Alright, B is connected to A and also C. So C is the shortest. So the option is C. And also we have D. D is connected to C. Also D is connected to E. E to D, C to D, or B to D, but B we don't have yet. So C to D and B to D, which one is the shortest? So we have this. So A to C to D, we have 11 earlier, so it's just the same one. And also we have A, C to D, it's just the same one, this previous one, right? A to C to B is 7. Alright, so we just choose the lowest from here. So this is the shortest. So when the shortest is 7, we need to choose, so it is B, right? So we have A, we have C, we have B, we have E. This is the path. Alright. So next, to get D, we can take it through B or we can take it through C. Right. Let's just calculate it like this. A to C, A to C, and then to B, and then to D from here, because this is the shortest, right? Compare A to C to B and to D. We have 3 plus 4 plus 2, we will get 9. So when I rewrite it again, 10, 7, 3, 11, 5, and it is 9. So this is our graph. So our graph will be A connected to C and go to B and go to D, and also this go to E. We have 2, we have 4, we have 3, we have 2. So we can choose this the shortest lah. Alright. To go to A to B is 7. A to B is 7. A to C is 3. And then A to D, we have go through A, C, B, D. Alright, so this is 9. And A to E will be 5 because we go through A to C to E. Right, so this is 5. This is the shortest path. Though this is the example for Dijkstra. Next, we move on to topological sort. Okay, this is the tree for topological sort. So to solve this, we need to list down 0 in degree Q, and also we need to list down in degree map. Alright, for in degree map, we need to find the in degree lah. So we start with A. Right, A. Is any node to A? No, right? So it is 0. How about B? B have 1. So B have 1. How about C? C have 1. C have 1. And then how about D? D have 0. How about F and E? E have 0. F, we have 2. 1 and 2. And then we have H. We have H. H have 1, 2, and 3. And finally, we have G. G have 0 in degree. So from this, we need to list down all 0 in degree Q. So we have A, we have D, we have E, and we have G. Alright, so we have A, we have D, we have E, and G. This is Q. Alright, so next, we can start removing, okay, when we want to sort it. So this is, I write the sorted. Good. Using topological sort. We will start with removing A. So when we remove A, we add A in the Q. So we remove A. When we remove A, B will decrease. So B will be 0. So when we rewrite it again, B with 0, the other one effect it. So I will just write once with number. So we will be 0. So C will be 1, F will be 2, H 3. Alright. So we add B here in the list Q. Then we remove A, we add D, E, G, and B. Alright, from here, we next remove D. When we remove D, we add D into sorted. So we remove D, and F will be changed. F will decrease by 1. So it won't change the in degree Q. 0 in degree Q will not change. So when I rewrite again, C1, F also have 1, and H still have 3. Alright, so it's just the same. Then I remove E. When I remove E, I need to add into sorted E here. So when I remove E, F and H will decrease by 1. This will be 0 and this will be 2. Alright, when we 0, we need to add into the list. 0 in degree Q. Alright, so this is F. So when I rewrite it again, we have G, we have B, and we have F. And also here, we have C1, we have F0, and H3, H2. Alright, next we remove G. When we remove G, there is no change, so it's still the same. Then we remove B. When we remove B, H and C will be removed too. So will be 0 and this will be 1. So when we rewrite again, this will be plus C, and also C 0 and H will be 1. Here will be F and C. Alright, so this will add B here. And then we remove F. When we remove F, we add F into the sorted list, so H will decrease by 1. So H will be 0, 2. So H is 0. Add into the list. So we have C and H. So when we sort, we remove C. Now we change and add C here. And we remove H and H here. So this is the sorted list. So this is the example for topological sort. That's all from me. Thank you.